Awesome, cool. Hi, everybody.
Hello.
Thanks for having us. Quite exciting to be here among all the brightest minds in the Bitcoin and Lightning space. We are Kwinten and Michael from Albi, where we're actually working on tools to bring the Lightning Network closer to the web. One of the tools that we're working on is the Albi browser extension. Maybe quick show of hands. Who has heard of Albi maybe or has used the browser extension? Oh, wow. Okay. That's more than I expected. That's cool. That's good because we actually don't talk too much about Albi today. We are more looking into some of the tools and also protocols that are needed to bring Lightning to the web. But maybe before we start with that, we first look a little bit into the past. And you might all have heard this maybe before, but I think it's quite important to understand and to see how the big significance that the Lightning Network will have also on anything that we're using on the web. And in 1991, the Hypertext Transfer Protocol was introduced. It's basically the foundation of all the communication that we do on the web. All the data on the web basically is transferred through the HTTP protocol. The version 1 of this protocol was released in 1996, and it actually already had the famous HTTP status code 402 included, which says payment required. So this kind of shows where already back then, people were thinking about how we get payments on the web there. And Mark Andreessen, the founder of Netscape, one of the first big commercial web browsers, actually says that it's the original sin that browsers didn't have payments enabled, didn't have money enabled. Because that meant that it was not possible to have actually an economic relationship between a server and a client. So it was on the web not possible to have an economic relationship between a publisher and a user. And yeah, the HTTP stack basically described that this is the payment required status code is reserved for future use. Many have tried to solve this problem, this digital cash problem, especially in the 90s. We've seen eCash, eCoins, Millicent, however they were called. PayPal actually also comes from end of the 90s, where it came to existence. Here's an old screenshot of an eCash application and also trying to do that. So what was the result of that, that we didn't have payments in there? We had a standardized way with HTTP and the web to transfer information. And with these open protocols, they drastically lowered friction. The distribution cost of information was lowered. And it got quite easy and cheap to transfer this information. So the barrier, like these open protocols that we had, they lowered the barriers of entries for publishers, for producers, for anybody to create things on the web. But we had no similar standardized way to transfer value in a similar way like we could do that with information. So the barrier of entry for financial services was still quite high. The transaction costs were still quite high. And that meant also that the innovation and creativity in that space was still quite low. And this, in turn, meant that companies had to move to an information-based business models, which basically means they resulted to use advertisement to monetize their products and their content on the web. And we know that, like everybody knows that all these cluttered websites with a lot of the web banners and so on, it was easy to transfer information. So what happened, actually, we were just adding advertisements to all the websites. So, and this, in turn, obviously leads to more centralization. The bigger platforms can monetize this data then better. It means more advertisement. It means more clickbait. We need to make the user click more and visit more things to monetize it. And this in turn means less quality of content, and especially less indie creators, less smaller companies that can work on these things, because it was just less ways of monetizing anything that was published on the web and created for the web. So, but finally, now with our magic internet money, we have this missing protocol, basically. So Bitcoin and Lightning is the missing protocol. With that, we managed to bring a truly digital native asset to the web, and we are able finally to similarly transfer value as we were able to transfer information before. So we can now basically attach payment flows to any user interaction on the web, and with that create completely new user interactions and create completely new ways of monetize content. So if we look at that, we got Bitcoin as the best monetary asset out there. We got Bitcoin, the network, and the Lightning Network as the open protocol that we can build on top of that. And now we are slowly seeing, with more tools evolving, and we are slowly seeing more and more applications that are built on top of those and that are integrating the Bitcoin and the Lightning network. The exciting thing here is we now can start using web technologies for that. The web is basically the most innovative platform. It's quite accessible for developers, but it's also quite accessible for users. And now we are at the stage where we can build with web technologies, HTML, JavaScript, CSS, and so on. We can build Bitcoin applications. This is also what we are kind of doing in Albi. So we're trying to be, or we're building tools that are the bridge between the user's nodes, different node backends that they can use, Core Lightning, LND. You can have your Raspberry Blitz running at home, connect that one to what we do with Albi, the browser extension, and with that then make the Lightning Network available for any website that you're using out there. So we are basically the bridge between the user and the websites. And all this is based on open standards. And the great thing about the web is actually the web has always been good at disintermediation. So it means like it was always cutting out middlemen. And software protocols basically cut out middlemen and increase innovation. And in the payment space now, we see that we no longer need payment service providers. A developer, a creator does no longer need to go to a payment service provider and ask to accept card payments and similar things. It's just an open protocol and you can just integrate with it. So payment flows now suddenly can be orchestrated through software. And this greatly reduces the development costs and the development effort, obviously. And that also means that we can now have different payment flows, and we can actually build applications that are no longer middlemen. They don't no longer need to be within the payment flow itself. They basically can orchestrate the payment flow directly. Let's go back one more slide from the user's node through the Lightning Network directly to the recipient's node. And we've heard that basically also just in the presentation before from guys who's building on open protocols basically allows that users can directly pay the recipient, and that is orchestrated through applications, through web applications that now can be built. So we kind of separate here the information flow from the value flow. As the team guys said before, this only is possible, and this greatly is possible because of interoperability, that's key, and open standards. And we're going to look now also at some of these standards, LNUL, LSAT, especially in the end, which is a quite interesting new protocol, and WebLN and WebBTC. Quite quickly, because we already talked about that, LNUL, maybe quick show of hands, who has scanned a QR code with a Lightning wallet and paid something here? That's probably everybody, yeah. So everybody has used the LNUL spec already. So the LNUL spec describes, it describes or it solves certain ways, certain problems, certain UX problems that the Lightning Network still has. Like, for example, how to get an invoice from a recipient to your Lightning wallet as a sender. This is the LNUL Pay protocol. There's also LNUL Withdraw, LNUL Auth. There are a bunch of these small, quite simple protocols and standards that can be used to integrate and create applications on top of that. Another one, a bit less known, as we've seen before, is WebLN, WebBTC, which is basically a set of specifications that allows Bitcoin and Lightning applications to communicate between the app itself, anything that happens in the browser, for example, or in the application, and the user's Lightning node. So it's a communication back and forth, which then means it provides a much better user experience because it allows native integration of these Lightning functionalities. That means you don't have to scan a QR code anymore on the web because we're in the digital world anyway already. You can directly just execute certain, or a developer can execute certain functionalities programmatically, and your wallet directly opens. So I can click a link, for example, or I can click a like button on a website, which then requests a payment, and your wallet automatically will take over and send the receipt of that payment back to the application. So this greatly improves the user experience and reduces the friction, especially for the user. It's actually already quite a bit of an old standard. It was initially released in 2019, but we've seen quite some pickup of interest in the recent time, in the recent months, and especially because we are now getting to the time where these tools are available, and here it becomes the integration of the Lightning functionality in websites just becomes really a matter of a few JavaScript lines. Here is a bunch of examples of these functions. So how it basically works: we have the user's wallet on the one side, and we have the Lightning application on the other side, and the application can programmatically call certain functions like sending a payment, like requesting an invoice, signing a message, and so on from the application. So you can think of it a little bit like when you use a video conference application, and this application gets access or requests access to the microphone or the camera. This is the similar standard that allows these applications to access certain functionalities or request access to certain functionalities of the wallet. Right now, it's mainly sending, receiving payments, but potentially this also evolves into more functionalities that we can, for example, also list channels, list peers, do any functionality that the Lightning Network currently provides. And with that, I'm passing it over to Kwinten to talk about LSAT. probably one of the lesser known standards. Yeah.
Thank you. Yes, so I'm going to talk a bit about LSAT. So earlier this year, Albi participated in the Summer of Bitcoin program, which is a program meant to connect university-level students in an internship at Bitcoin and Lightning companies. It's a paid internship, and so together with Dananjay, we built some software around LSAT. And so what is actually LSAT? So it's a very simple protocol. It was introduced also quite a long time ago in 2019 by Lightning Labs. And it's used in production today by Lightning Loop, which is a swap service to swap on-chain Bitcoin with off-chain Bitcoin in a trustless way. So it's basically just a way to talk to a server and first of all get a ticket, so a token that you are that you are authorized to fetch a resource, some kind of file, or do some kind of action. It's based on HTTP headers. So first of all, the client says that, okay, I am LSAT enabled, and the server answers with a macaroon, which is a token, and together with this macaroon, there is an invoice, so a Lightning invoice, and when you pay this invoice, so the invoice is returned to the client, and the client then pays the invoice, and then the proof of payment of the invoice is called a pre-image. This pre-image should be sent in the second request to the server together with the first macaroon, and this actually proves to the server that you paid this invoice and you are now authorized to use these resources that are protected by the macaroon. And so it's you can look up the specification. It's open source. But in the end, it's a very simple way of communicating, like invoice negotiation, communicating between a client and a server about, okay, I want to access something, give me an invoice, and then okay, I prove that I pay this invoice. So here we have some code, finally. So enough of the mantras, show me the code, here's some code. So basically, what if I want to access an MP3 file and I say that I am a client that is actually able to pay LSAT invoices? And what the server will respond is below. And so it has a www authenticate header, which contains two parts. As you can see there, the first it says LSAT, and then it says macaroon equals, and then that's the macaroon. And then after some time it says invoice, that's here, and then there is this invoice. And so an invoice always has a payment hash, which is the hash of the pre-image, and actually the same payment hash is also inside the macaroon. So the macaroon and the invoice are connected through this payment hash. And so the status code 402 payment required. And so what if you then the client pays this invoice, and then they are ready to make the second part of the handshake, which you are supposed to send another header, accept authenticate LSAT, and then authorization. And then here you have the LSAT, which is basically also two parts. Again, the same macaroon that you got in the beginning, and also the pre-image, which is this last part, this number, which is hex encoded. And then this is basically the entire protocol. So as you can see, it's quite simple. And here, the MP3 file is returned. So here you can see, so for the people that are watching this on YouTube, you are now looking at the YouTube stream of a YouTube stream, which is kind of, so what they made here is Lightning Labs made some program called Aperture, which is a reverse proxy. So it's a server which sits between a backend server and the internet. So when a client makes a request, they get this response about the LSAT response. So over here you can see the architecture of this program. So it has a database, it's connected to a Lightning node, it's connected to a backend service, and the user makes, well, requests to this reverse proxy. So this Aperture, it was released earlier this year, or might exist for some time, it's used in production by Lightning Labs to power Lightning Loop. But we thought that, okay, it's a very cool showcase, or it's a very cool product, but it's missing something. We can do maybe a bit better. So what are the things that you need? You need a Lightning node in order to run this server. And actually, that's a problem for a lot of people. You need to run a Lightning node in your infrastructure. That's not always, let's say, it's another thing that developers have to do. So you need to run it as a separate server, and you also need a database, and it also needs a second backend server to be able to run over HTTP or over gRPC. So what we thought is that, okay, and here some more code, but what we thought is that, okay, we can implement a middleware library which was using Go. So Go is a very well-known language to do web development in the backend mainly, and there is this framework called Gin, and we made a middleware library to be able to insert these LSAT invoices into the web framework basically. And so what are the advantages compared to Aperture is that so you don't need to run your own Lightning node. We made it a plug and play system that you can write your own Lightning provider, bring your own. So this can be a Lightning address, this can be your own Lightning node, this can be an LND node, this can be a C Lightning node. Basically it can be whatever you want. And there are also more things that you can do. For example, you can set a dynamic price based on what resources clients are requesting, and we made sure to try and make it as flexible as possible. So how you can do is, so you can use this library in all kinds of ways. You can run it as a proxy server, or you can use it to write a proxy server, which would be similar to what Aperture is doing, or you can integrate it into your monolithic monorepo stack. So it's quite flexible in that way. And so the real main strength of this is that if you decide to use Lightning Address as an invoice provider, then the application itself, the server, does not need access to a Lightning node, which is actually a very powerful concept if you think about it. So this couples out this dependency that the server needs to be in the payment flow. But the powerful part is that the server can verify that the payment happened without being in the payment flow, because the client presents the proof of the payment as part of the protocol, but the server does not need to be in between the payment flow. So that's actually very powerful, the most powerful part of this program. So you can use this for monetizing your files. You can use it for, like Lightning is doing, liquidity services, or all kinds of things. And so it also allows you to monetize your service without users having an account. So that's yeah, that's actually a very the main use case, how you can monetize content without requiring users to have an account. So, and then we have, yeah, so after the middleware library was finished, we made some showcases to show to developers what you can do with it. So this is the Albi mixtape. So what people can do here is that they can upload their tracks, their music, and then they can put in their Lightning address, and then other people can buy this music by paying over WebLN using the Albi extension, and that's why we think this is actually a match made in heaven. So the powerful thing is that WebLN also has the capability to return a pre-image. So this pre-image that is returned by WebLN is filled into the LSAT header, and so these things kind of work together very well, and users don't need to put in one Lightning address. They can put, doesn't need to be a Lightning address of the website. They can put in all kinds of Lightning addresses that go to all kinds of different service providers, and it works exactly the same. And so, yeah, one thing we are working on in Albi is to do some kind of WebLN.LSAT.fetch. So a developer just needs to ask Albi to, let's say, okay, I want to fetch this website, and if you want to, if it needs me to pay, then pay directly to the website. And so that's something that we are working about on to make this as easy for developers as possible. Yeah, so this was something that I was explaining, that this all fits together very nicely. And so WebLN is used from the user's node or the user's wallet to connect to the website, and then LSAT is used between the front end and the back end of the server, and then LNURL is used to fetch the invoice, which is a possible stack that you can use to to buy applications. And yeah, so there is also, we are wrapping up now. But so if you are interested in Lightning development, please join us on bol.fun, which is a website related to Lightning development. There's a tournament starting today, I think. It's called Legends of Lightning. So if you're a developer who want to develop on Lightning, you can join us there. So this is a bol.fun website, and I think that's it. Thank you very much.